Now children, I am going to explain some more properties of matter, different forms of matter, whether it is solid, liquid or gas. And the first property is diffusion. So diffusion, it is the intermixing spontaneously of a substance on its own. So it is defined as the spontaneous mixing of particles of a substance. Spontaneous mixing. Spontaneous means on its own, without the help of external agency. External agency means, suppose we are dissolving sugar, and so we use spoon. So if it is not a spoon on its own, that's why it is spontaneous, means quickly. On its own, substance into other substance. So it is the diffusion. So children, there are many examples. First, a smell of perfume. You all have the experience. When we burn incense stick, agarbatti, during puja, what happens? If there is no fan, no air, all the window panes, the doors are closed. What you notice? If a small drop of perfume is very carefully cooked in a corner, within a couple of minutes, entire room is full of the smell. So why it is so? Because of the diffusion. So children, a smell of perfume, a smell of food materials, and in food materials also, there are two conditions. Two conditions are there. If food is hot, then the smell reaches quickly. The smell reaches quickly to other rooms. This is one condition. If food is cold, then we have to go closer. Children, you have to go closer. You all have the experience. In the kitchen, when something is being cooked, say ice cream is being eaten at some place, so no one knows. You take out ice cream from fridge, start eating. Nobody knows because the temperature of ice cream is very low. So the particles of the ice cream, they do not spread throughout the building, throughout the quarter. But when it is, say Maggie, you prepare Maggie, you prepare tea, you prepare coffee. Coffee is very strong smell. Maggie is very strong smell because it is being heated at high temperature. Halwa is being made. Pakoras are being fried. So that's why I mentioned that if food is hot, then the smell reaches quickly to other rooms due to high temperature. So here, why is so? Temperature is high, and the particles of food, they travel more distance. Here, temperature is low, so we have to go closer. So this is about the diffusion. Now, other point that the property of diffusion is maximum for gases. Maximum for gases, then for the liquid, and much less for the solid. So here it is the maximum, here it is the minimum. If there is chalk in my hand, I put here or you stick here, keep it for years, very small amount will be diffused, but gases, they diffuse. Similarly, you dissolve rose syrup to make the sherbet. What happens? You stir with the spoon. So this is the diffusion. So gas is very high, a smell of the hot food, and so this is all about the diffusion. Now this is the second very important point, property of the matter, and it is compression. Compression to confine to a place. You all must know, if there is a syringe and almost syringe, and here it is the mouth, here there is the piston, and you all have the experience of taking injection. If the compounder or nurse or doctor compresses here, what happens? Then it comes here, it comes down. The piston comes down, and here it is the condition. Why is so? Because air has less, molecules. Air has less molecules in a given space. That is, more gap is there, and so we can compress. So this is compression. Similarly, compressor in the shops who fill air in the tires of the automobiles, bicycles. So they have the compressor machine. So here it is a compression. Now compression, how to define the compression? So general compression is defined as the property of matter due to which it can be restricted or forced. We apply force, we define volume, we limit the volume. Force to occupy less area by applying pressure. We apply pressure. Just you have seen in the syringe, applying pressure, and by lowering temperature. You all know, whenever you feel air in your bicycle or in the football, what happens? The lower portion of the pump becomes hot. Why? Because air is being compressed by applying force, and so that's why. So it is compression, and the property of children compression is, again, it is maximum for the gases, then medium for the liquid, and for the solids it is very, very low, almost little, because in case of gases, the particles, here the particles are far away. Particles are far away means large distances. So by applying pressure, the gas can be compressed. Similarly, in case of liquids, the particles have slightly less space than that of the solids, this gases, so liquids can be compressed, like the case of injection. Similarly, in case of solids, the particles are compact, so they cannot be there. Now, in other ways, now children, I am going to explain some more about the compression. You all know, we have the LPG. LPG stands for liquefied petroleum gas. You know LPG in our kitchen. Then CNG, compressed natural gas. LPG and CNG, liquefied petroleum gas, CNG, compressed natural gas. And you know, they are used for cooking. They are uses. So, uses in cooking, then running of vehicles, then in industry. Industries also children, like fertilizers. Fertilizers are made using CNG. CNG especially, CNG is used in making fertilizer. Now children, some more point about the CNG. Actually, children, CNG is basically natural gas. Here, natural gas is in compressed form, so it is methane. It is methane gas. Methane gas is obtained from the oil wells or gas wells, but it is formed by the decomposition of organic matter which were buried inside the earth millions of years ago. And so methane is the major component. In addition to methane, there can be hydrogen. So methane is the most important component. Methane, there can be little amount of hydrogen, there can be little amount of water vapors of water, so they are very less. Then this LPG, you know, it is obtained as a gaseous product due to the distillation of crude oil or destructive distillation of crude oil, so it is butane. So children have to keep in mind, butane is the major component of LPG. In addition to butane, there can be ethane also. Ethane, there can be propane. But ethane and propane are much less. And so this is about the compression. Now, one more application of compression, children. Here it is dry ice. So dry ice is nothing but it is solid form of CO2. It is solid carbon dioxide. So what is dry ice? Dry ice is solid carbon dioxide. And so how it is made? Again by compression. So carbon dioxide gas here at high pressure is very high and very low temperature, and there is formation of carbon dioxide solid. This is called as dry ice. And why it is called dry ice? Because it undergoes sublimation. Sublimation is other property, children, of the matter. So it is called dry ice as it is converted. It is converted into gas without going to liquid state. Without going to liquid state. That's why it is called a dry ice. Suppose we take dry ice to any vessel, so it will not wet the vessel. We cannot take dry ice on our palm because the temperature of dry ice is very low. It will burn our skin. So it do not wet the vessel. Now its usage of dry ice, number one, in cosmetic surgery. Cosmetic surgery, cosmetic surgery, face surgery, the scars of the face. Pigmentation can be removed by the cosmetic surgeons. Then, in preserving easily perishable items, like ice cream. When we have to transport ice cream at a place where there is no electricity, or you have to transport in a vehicle without electricity, so we keep the ice cream or that material in a closed box. Then the dry ice bricks. Actually, the dry ice is available in different forms, either balls or the pellets or the bricks. So it is there. So like you have to carry the fishes. So fishes are kept into boxes made up of thermocol, or flowers are kept in boxes of thermocol, and then the dry ice. So dry ice is not commonly used, but it is for very expensive flowers. Flowers are very expensive. They have to be brought from the foreign countries or from the different places. So it is very important point, dry ice, and it is nothing but it is solid carbon dioxide. Children, next important point is latent heat. Latent means hidden. And heat, it is Greek word latent. So latent heat is the amount of energy which is present inside the matter or substances which is responsible for some of the properties. So it is the amount of heat energy hidden or present inside a substance, and responsible for some of the properties which are unusual, like for example steam. Steam causes severe burns. Steam from the water. Steam causes severe burns. Then that of boiling water at the same temperature. You all have the experience. The steam coming out from the boiling water, it is more dangerous than that of the boiling water, because the latent heat of the steam is very high. You all have the experience. Latent heat of steam is very high, and so it means it is highly energetic. So it is having more tendency to harm, or it has more energy. And so it causes severe burns. Now children, next important point is rigidity. So rigidity or hardness. So rigidity or hardness, children, means the property of a substance due to which it maintains a tough position. Like this chalk, it is hard, it is rigid. We cannot break it easily. So it is the property of matter, due to which it is able to maintain tough posture or fixed position. So all the solids are, what you say, hard and rigid. All the solids are hard and rigid because the force of attraction between particles is very high. So this is the meaning of hardness and rigidity. Now children, next point is kinetic energy. Kinetic energy, it is also written as Ke, and it is mathematically half mv square. Kinetic energy. So this is m. M is the mass. What is m? M is the mass of particle or body. V is velocity of particle. So kinetic energy, children, it is the property of the particles or the matter having a particular motion or velocity. So all the moving objects have kinetic energy. All the moving objects have kinetic energy, and so it is there. So energy associated with moving body. What you say? Energy associated with moving bodies. Energy associated with moving bodies is called as kinetic energy. Now next point is density. So children, density simply So density is defined as the property of matter. Property of matter due to which the particles are present in more compact form or less compact form. So density basically distinguishes the composition of particles, and so mathematically density is equal to mass upon volume. Mass upon volume. Mathematically density is having this Greek. This is called as rho. Rho is equal to mass upon volume, and if mass is in gram and volume is centimeter cube, volume, like if we have this vessel, so the arms are L, and L, so it will be cm, the cm, so it will be gram per centimeter cube. So this is about the density. So solids, coming to main point, solids have high density. So solids have much more density than the liquid, and the gases they have almost no density. Gases, they scatter. Gases are scarce. The molecules of gases are, able to scatter throughout. So this is all about the density.